Hello, this is Mr. Huber. In this video, I'm going to go through solving some trig equations with special cases where we have something involving extraneous solutions. Okay, so if we see this first equation here, and we want to solve this, or our keys are to try and simplify it to a single trig function whenever possible. So if we look at cotangent times sine, okay, cotangent is cosine over sine times sine, those will cancel. So I'll end up with 1 plus cosine theta equals 0. And if we subtract the 1 on both sides, we'll end up with cosine theta equals -1. And so when we get to this point, now we want to find out what angle measures gives a cosine value of -1. Since cosine is the ratio of x over r, in the unit circle, when r is 1, really we want to find out when is x going to be -1. So it's really saying when is x -1. All right, well, on our unit circle in the coordinate plane, okay, x value of -1 would be out here at -1, 0. That would be at 180 degrees. When we talk about that, we can go back again and say, okay, that's true. Cosine of 180 is -1, so 180 should be my answer for theta. We have to make sure we check answers in original equations. This is true anytime we've solved equations. You first started learning about solving basic algebra equations for a variable, like finding out what x equaled. You want to check it and plug it back in. Always plug it into the original equation, not some other step along the way. So in this particular problem, if we want to check this and plug it back in, we want to go back up to our original equation, right? We want to go back up here to the original equation. Don't plug it in one of these steps where it's going to look like maybe something's working when it wouldn't. Always check and plug it back in here. So we're going to put 180 in here and in here. And what's going to happen to make an extraneous solution is if one of these is undefined. So really, the only functions we need to worry about being undefined is when there'd be a denominator of 0. That can't be for sine or cosine. Sine and cosine are both over r, and r is always going to be 1. So when we look at this, really we want to know tangent, cotangent. Okay, let's go back and fix that. Cotangent, secant, and cosecant. We want to know when could those be undefined. That would be when they have denominators of 0. So we're trying to figure out if that could be the case. So cotangent, in this case, we have cotangent in our original equation. So I want to see when would cotangent be equal to have a denominator of 0, right? Since cotangent is x over y, I cannot have cotangent where y is 0, okay, because that would be undefined. And in this particular case, right, we have y equals 0. So if I plugged into my original equation and did cotangent 180, and it doesn't really matter what's after that, sine of anything, okay, I'll put theta there, it's 180, but it really doesn't, this part doesn't matter. This would be undefined. Since that's undefined, 180 cannot be a solution to my equation, and since it was the only solution doesn't work, then this problem, the answer would be no solution. There's no solution to the original equation we had in this particular problem. We got the 180 degrees, which worked based on the steps we did, but when we check it back in the original equation, it's not that we did anything wrong, but we introduced an extraneous solution there by working with those trig functions, and instead of having cotangent as we went through the steps, it became cosine when we multiplied it. So be looking out for those. I'm going to do another example here, and you just always want to make sure you're checking and you're looking for these situations where one of these 4 trig functions would have a denominator of 0. If it does, then that can't be one of the solutions for your equation. All right, so let's see another example here. And we see a problem like this. We have cosine times secant plus cosine equals 0. So I could factor out a cosine from both of these terms. I get cosine theta, secant theta, plus 1 equals 0. When I have a factored equation equal to 0, I can take each of my factors and set them equal to 0. So I can have cosine equal to 0, and then secant plus 1 equal to 0. So now if I go back to here in my first setup, cosine theta equals 0, I would want to know, again, cosine is x over r, So I need an x value of 0. That's at theta is 90 degrees and 270 degrees, right? If we talk about on our unit circle, here, that'd be 0, 1, and 0, -1. Those would be my two places where x is 0. So if my numerator is x for cosine is 0, then I'll get a value of 0. So 90 and 270 are my solutions there so far. And then in this next one, I would subtract 1 on both sides and get secant theta equals -1. All right, so secant is the reciprocal of cosine, so it's going to be r over x. Since r is always 1, we're looking for where x would be -1. Okay, x would be -1, right, out here at 180 degrees. Okay, so we'd have theta equals 180 degrees. So it looks like I've got three answers, 90, 270, and 180. I need to go back and check in my original equation. And one of the things we want to check for is where we could have an undefined trig function. Sine and cosine are never going to be undefined. Sine and cosine are never going to be undefined because they're over r, which is never going to be 0. But in this case, we have secant. Okay, so secant, okay, if that's going to have a 0 in the denominator, okay, r over x, we don't want to have an answer where the x value is 0, or secant would be undefined. Well, if we look back to the 90 and 270 over here, right, they have x values of 0. So since our x value is 0 for 90 and 270, those cannot be solutions to my original equation. If I took those answers and I plugged 90 back in up here to my original equation, okay, for secant, I would have undefined times something you can't multiply by undefined. It's just undefined, so it wouldn't work. We can't plug it back in. So same with 270. We plug that back in. Secant 270 is undefined. That means it can't be a solution to the original equation. So 90 and 270 are not answers. Our only solution then is going to be the 180 degrees. So that would be our final answer, 180 degrees for theta. So we're solving this the same as any other trig function equations. All right, try and simplify it down to a single trig function, or these factored forms. We can set factors equal to 0. The different things we've looked at for simplifying, using identities and getting the trig function values, and then figure out what angle measure will give us those ratios. The key is to make sure you're plugging answers back in. We hadn't seen extraneous solutions in our first sets of problems. Those are possible, so they're getting introduced now, and you want to look out for those as you continue to work through these types of problems. So practice those, check for extraneous solutions. As you start to see these more often, again, you're going to look for just the 4 trig functions, not sine and cosine, that can be undefined, and figure out and make sure you're not plugging in theta values that will give you undefined secant, cosecant, tangent, or cotangent.